Kia ora boys, and I hope that you have enjoyed your little video on igneous rocks. We're now moving on to sedimentary. Now, just as before, you need to make sure you have your rock flowchart that you have been filling in, and you will need the sedimentary reference table. Once you have those two in front of you, continue on with this video and learn heaps. In this video, we're going to be talking about sedimentary rocks. Please make sure you have your rocks flowchart ready, as we're going to be filling in yet another portion of it today. So let's get started. Of course, as I mentioned, we're talking about sedimentary rocks, or the second variety of rocks in our rocks chapter. Please recall that rocks are classified according to the way in which they are formed. So, for example, remember the igneous rocks formed from cooling and solidification of magma or lava. Now, sedimentary rocks form in an entirely different way. The general way in which most sedimentary rocks form is from the compaction and cementation of the sediments. Now, there are some words there that we need to talk about first. So, compaction means what you might think, compacting or squeezing together. Cementation means gluing or cementing or sticking together of these sediments. But that brings up yet another question. So if these rocks are formed from that compaction and cementation, the squeezing and gluing of sediments, what exactly are sediments? Sediments are fragments, the little bits of rock that have been broken down as a result of a process known as weathering. Weathering includes wind and ice, running water, etc. So, imagine you are having a big boulder sitting in your backyard. If you were to somehow magically leave the earth and come back 10,000 years from now, that boulder might look very different, as a result of years of wind blowing against it, ice cracking it apart, and water flowing over its surface. It will have broken down into smaller and smaller pieces. That's what sediments are, the small fragments that result from the weathering of rock. Sediments, interestingly, are classified according to their size. So, we actually have 6 categories of sediments. The smallest being clay, then silt, then sand, then pebbles, cobbles, and boulders being the largest. So you've heard the term sand before now. You know that it is actually just refers to a size of particle and not a specific material. If you wanted to know the specific sizes that make up sediments that fall into any of these categories, you will see this graph. If you want to know the specific sizes that make up the sediments that fall into any of these categories, and if you look at this chart on the right hand side, you will see all of the names of the different sizes along with their respective sizes on the left. Let's use sand as an example. For a sediment to be considered sand, it would have to be between 0.006 centimeters and 0.2 centimeters. Anything bigger would be a different type, as would anything smaller. Another example, boulders. Boulders are considered any sediment that is larger than 25.6 centimeters in size. Now, let's talk about the first type of sedimentary rock, because there really are only 3 types, and the first of these is called clastic sedimentary rock. Now, a clast is actually just a fancy word for sediment. So these are actually the types that we have already been discussing. These classic sedimentary rocks form from compacted sediments, and these are generally classified according to their size. Let's take a look at the sedimentary rocks reference table. Now, if you notice under the grain size, you can see that the different size sediments that make up each of the rock's composition tells you what the minerals you would likely see. Comments are just some important information, and then there's of course the names of these rocks. So let's take a look at some of these clastic sedimentary rocks. Beginning with the first one, conglomerate. Conglomerate is composed of all different size sediments, or class compacted and cemented together, so that you'll have big cobble pebbles, maybe even some boulder compacted in there, some salt and clay. I noticed that the sediments in the conglomerate are rounded out, likely due to the flow of water that ran over them sometime in the past. Very similar to conglomerate is Precipitates. Precipitates is made from all different sized sediments compacted and cemented together. The difference being that the sediments in Precipitates are not rounded. They are more angular, pointy or jagged. And then we get to the sandstone. As you can see and imagine, sandstone is made of compacted sand grains. Siltstone is made of compacted silt, and shale is made of compacted clay. So, those are the classic sedimentary rocks. Compacted and cemented sediments. Now back to our chart. Let's look at another type. Let's actually look at two other types. We have organic and crystalline sedimentary rocks. For the crystalline, we have things called evaporites and precipitates. And then, for the organic, we have what we call biological matter rocks or bioclastic rocks. Let's talk about these because they're a little bit more complex. First off, the crystalline rocks seen here on the reference table. So these are under a column that says chemically or organically formed sedimentary rocks. So these are not necessarily from compacted sediments. In fact, the crystalline ones form in an entirely different way. So, crystalline sedimentary rocks are known as evaporites or precipitates. And what that means is that they actually form as a result of some sort of chemical process. Let's take a look at some of the examples. This is probably the best example. Rock salt. Now, rock salt forms from seawater, which of course has salt or halite dissolved in it, and when the water evaporates, the salt stays behind in the form of crystals. Those crystals, the rock salt. This is a chemical reaction, whether it's evaporation or precipitation. The result would be rock salt, gypsum, or dolostone. But what about these biological rocks? The bioclastic rocks. Now these form from compacted organic material or organic matter. We already know some examples of these, which include coal, which forms from compacted plant remains. And then there's this, which is a variety of limestone called quina. And you'll notice this is made from compacted shells. Shells, of course, are made by sea creatures. This is organic material, and so being classified as a bioplastic rock. One more key note about sedimentary rocks is that they are the only type of rock that may contain fossils or evidence of past life. So if you see a rock which has a fossil in it, you automatically know it must be sedimentary rock. The reason being, the processes that involved in the formation of igneous and metamorphic rocks involve a lot of heat and pressure. And so, these processes would destroy any fossils that existed there. The only type of rocks that really commonly contain fossils are the sedimentary rocks.